Hello Junior Tickies, and welcome to this video on bond length, bond energy and bond order. My name is Natasha Barton, and today I am very happy to be on this journey with you towards understanding each of these concepts a bit better. The first set of problems that we will be dealing with come from the KZN Common Test that was written in March 2019. This question says, the graph below shows how the potential energy varies with the distance between the nuclei of two nitrogen atoms when a double bond between the nitrogen atoms is formed. In order to answer question A to C, we need to know how to analyze the graph that has been given to us. So, I would like to remind you that when two atoms are brought close enough to each other, they experience forces of attraction. The electrons of the one atom are attracted to the protons of the other atom. But they also experience forces of repulsion because the electrons of the one atom are repelled by the electrons of the other atom, and the positive nuclei repel each other as well. Based on this, we know that when atoms are very far apart, they experience almost no forces. But they bring them closer together, they will experience a net force of attraction. At some point, the net force becomes zero, and they reach a state of minimum energy and maximum stability. It is at this point that a bond will form. Move these atoms even closer together, and they will experience net forces of repulsion. And this is what is responsible for the sharp peak in the curve that you see on your screen. We can now answer question A to question B. Question A says, what is the bond length in picometers of the nitrogen double bond? In order to answer this question, we need to remember what bond length is. Bond length is the average distance between the nuclei of two bonded atoms. Based on this, we know that we can find bond length or read bond length off of the x-axis of this graph. We go to the point, to the place of minimum energy, maximum stability, and we read up to the x-axis, where we find that the bond length is 125 picometers. Ladies and gentlemen, it is very important that you state your unit of measurement or you will not get the marks that you should. Question B says the bond energy of the nitrogen triple bond is 946 kilojoules per mole. Will the bond length of the nitrogen triple bond be greater than, less than, or equal to your answer to question A? We can start off by finding out what the bond energy of this nitrogen double bond is. We read it off of the y-axis of the graph and find that it is 418 kilojoules per mole. Since 418 is smaller than 946, we can conclude that the nitrogen triple bond is stronger than the double bond, and therefore more energy will be absorbed in order to break this triple bond. There is a relationship between bond order, bond strength, and bond length. As bond order increases, bond strength increases. We therefore say that in general, a triple bond is stronger than a double bond. But as bond order increases, we also find that bond length decreases. This means that atoms in a triple bond are closer together than those in a double bond. We can therefore conclude that the answer to question B is less than. The bond length of the nitrogen triple bond is shorter. The atoms are closer together than those in the nitrogen double bond. We can now move on to question C, which reads, what is the relationship between bond length and bond energy? We already know that the bond energy of the triple bond is 946 kilojoules per mole, while that of the double bond is 418 kilojoules per mole. 946 is the bigger bond energy, but the nitrogen triple bond has a shorter bond length. We can therefore answer question C by saying, as the bond length decreases, the bond energy increases. This brings us to the end of this KZN question from the KZN question paper, and we can now move on to the last question in this video. This question reads, which molecule, HCl or HF, has a greater bond length? We can start off by remembering which variables are related to bond length. We can start off with bond strength. In this question, we have not been provided with any bond energies, so we can't possibly make use of bond strength. Secondly, we have bond order. But notice that the bond between hydrogen and chlorine is a single bond, and that between hydrogen and fluorine is also a single bond. So contained in both of these molecules are single bonds, and we therefore can't make use of bond order. The last variable that we can compare is atom size. Although both molecules contain hydrogen as one of their atoms, we can compare the chlorine atom to the fluorine atom. We will therefore make use of atom size in order to answer this question. I would like to remind you of the trends that we find in the periodic table. We say that as we go from top to bottom in a group, the atom size increases. Fluorine and chlorine are in the same group, with chlorine being below fluorine. This means that fluorine is a smaller atom than chlorine. If we draw these molecules, with chlorine being a bigger atom than fluorine, you will notice that the distance between the nucleus of the hydrogen and chlorine atom is longer than that between the hydrogen and fluorine atom. We can therefore answer this question by saying that the HCl will have the greater bond length. Ladies and gentlemen, this brings us to the end of this video. The video that follows this one will involve more exam questions, so I hope that you will join me in that video, as I will give you hints and tips on how to answer your exam questions and to secure your marks. Thank you so much for joining me in this video.